Since the beginning of the course, we've been talking about the fundamental parts of an information system being input, processing, output, and storage. One other part that we haven't really focused on yet is communications, and that involves not just the computer, one computer itself processing the data that we give it, but the communication between multiple computers and other devices. So Chapter 4 kind of gives us a little focus on that. Basically, we're going to be talking about networks and the internet and how they are used in information systems. So we'll talk about the components of a telecommunications system, and we'll talk about the different types of networks that organizations can choose from, and take a look at the differences in those. We'll also talk about, which might be an obvious component, but how the internet provides the infrastructure for delivering and accessing information and services. We'll learn a little bit about how the internet works. Some might consider the internet and the World Wide Web the same thing, but we need to recognize, particularly as information systems professionals, that the web is just a component of the internet. It's the component that contains these documents with hypertext and multimedia. The internet, however, is a much larger set of processes and communications, but the World Wide Web in organizations is one very important area of the internet. So we'll take a closer look at that. In particular, we'll take a look at how the internet and the web can improve collaboration in an organization, socializing, and just make the business experience much, much better. You were introduced to intranets and extranets in one of the earlier chapters, but here we'll focus a little bit more on how they actually work and what types of technologies you find in intranets and extranets. In any class like this, dealing with computer literacy, information systems literacy, and even management information systems literacy, it's important to really focus on telecommunications and networks, because no matter what field you'll be going into, it will be a large part of what you do at work. Very often I wish that we had a better video conferencing technology between the campuses at our school, because it would save a lot of traveling. That's just one of the many ways that telecommunications can be used to improve businesses. So what are telecommunications? Simply stated, it's just the electronic transmission of signals for communications. And a telecommunications medium, and what we want to think of as mediums, are things like wires and then wireless communications. It's any material substance that carries an electronic signal to support communications between a sending and a receiving device. Generally, the sending and receiving devices are computers or devices like printers or other types of devices that can receive a signal. These are the basic components. You'll see them numbered here. In any telecommunications, you've got a sending computer that sends a request or some type of signal. It sends it through a medium like a wire or a wireless communications. We'll learn a little bit more about that. Radio waves, satellite, even microwaves. But that medium provides a path for that signal to a telecommunications device like a modem or a network interface card. And that telecommunications device translates that signal into a mode in which it can be sent along another type of communications path or medium, such as a telephone wire. This is kind of an old illustration of telephone wires relating to the old dial-up networks. But in general, it is a series of some type of cables that's transmitting these signals. And then finally, on the other end, on the receiving end, there is a telecommunications device that will receive that communication or that signal, using another medium to send that signal finally to a receiving device. So these four basic components: the sending computer, the communications device, and the mediums along the way, finally the receiving device on the other end. These four components are found in every type of telecommunications that we use. The term channel bandwidth is a term that relates to the rate at which data is exchanged. We have fast bandwidths and slow bandwidths. Typically a broadband communications bandwidth is very fast, and that's generally what we use, especially in businesses, but even in our home computer networks. Communications media, like I mentioned before, it's just anything that can carry a signal, and there are many different types. The wireless communications media that we're used to, microwaves, radio waves, infrared waves, they provide the way to transfer the signal through a particular frequency. These are some examples of some wired communications media. Twisted pair cable is the most common type of media you'll find in regular networks in offices and homes. Coaxial cable is another type of pretty common wire. Fiber optic cable is used in very large networks that require high rates of speed because it is capable of very high transmission rates. And then broadband over power lines is another way of transmitting data. This is one way that cable and phone service and network services are provided to rural areas where there might not be easy access to those services. Some of the different types of wireless communications standards that are used today in communications such as cell phones and multimedia streaming, and even providing wireless access to large groups of people, citywide access for people to be able to connect to the internet without their own hotspot or being in a local hotspot, but being able to connect to a general network that is not, that could be worldwide. But 3G, or third generation wireless communication, supports wireless voice and broadband speed data communications in a mobile environment. It was one of the first standards developed for smartphones to enable smartphones to be able to stream data and give somewhat high performance in data transmission. The fourth generation wireless communication has improved on that and is trying to provide even smoother transmission of streamed data, and so it's just a little bit more data speed. And then the worldwide interoperability for microwave access, or WiMAX, is the standard I was talking about for metropolitan area networks to give access to people to the internet without having to connect to a nationwide network, but it would be kind of a metropolitan or region-wide network. Some of the heaviest users of these wireless technologies are smartphones. And a smartphone is basically a small computer that has the capability of a phone, but it also would include a camera, a web browser, email, and could include an MP3 player, and all kinds of other devices combined into the smartphone. They generally have their own operating system, and they generally accept the installation of apps, applications, which are just small little programs that can be added to the smartphone to do various tasks. Sometimes the manufacturer will provide a set of these when the phone is developed. Also, the operators of the communications network will provide apps, and then you can build your own apps if you would like. Any third-party software developer can create an app designed for a smartphone and make it available. Of the four components that we talked about being necessary for telecommunications, one of those is a telecommunications device. And here in this table, table 4.4 from page 168, you just see several examples of what we would consider telecommunications devices. First on the list being the modem, translating data from a digital form as it is stored in the computer into an analog signal that can be transmitted over telephone lines. Again, this is kind of an old-fashioned way of looking at it. Modems generally now don't have to do that because it's a full digital transmission. The computer generates a digital signal and the lines over which it's transmitted are also digital. But in the beginning, that's what the modem did. It translated digital into analog. Then we have several others that you're familiar with: fax modems, multiplexers, PBX machines, front-end processors, switch, bridge. The router is the next one I'll mention. The router is the crux of any network. It forwards data packets across two or more distinct networks. The router works similar to a human router in a post office, where it looks at the address of the package or the mail and determines what is the best route to send this package to get it there in the fastest amount of time. So routers recognize addresses in multiple networks, and they're placed in between networks to be able to take a signal from one network and then transmit it to another network